9.4 notes. We're going to start over here. We've got the sine curve. We're throwing it on the coordinate plane. Okay, so this is going to be big now. Big day. Okay, here we go. So I've kind of got a part of a circle here, and we can envision this coming all the way around. And I've got my theta, and when I do opposite over hypotenuse, that's what gives me the sine is y over r, and the cosine then is adjacent over hypotenuse, and the tangent is opposite over adjacent, y over x. So when I do this on here, I go left 3, up 4, Pythagorean theorem. 3 squared plus 4 squared is 25 in the square root, and I get 5. This is the angle I work off of, and now I get that the sine of the angle is equal to opposite over hypotenuse. The cosine of the angle is adjacent over hypotenuse, and the tangent of the angle is opposite over adjacent. When we flip them, then we have 5/4, and we flip them, and we have negative 5/3, and we flip them, and we have negative 3/4. Whoa, 3/4. Almost made my first mistake of the year. Not bad, not bad. Okay, so we can get off of a coordinate plane exactly what we're looking for here. The first thing I need to do here is I need to do the Pythagorean theorem. 15 squared plus 8 squared is 289, the square root of 289. So I'm looking at 8, negative 15. Pythagorean theorem tells me this is 17. Again, yeah, that's the angle, but we're always kind of working off this reference angle right here. So again, I'm going to do the sine of the angle opposite over hypotenuse, negative 15/17. Cosine adjacent over hypotenuse, tangent opposite over adjacent, and then the cosecant we flip. 17/15, got to have a negative, and then the secant we flip. 17/8, and the cotangent we flip, and we get negative 8/15. Notice the sine in quadrant 4 is negative, but the cosine in quadrant 4 is positive. Ooh, foreshadowing. Things to come are going to be wonderful. And the tangent in quadrant 4 would be negative as well. Same thing here. They're telling us go to 4, negative 10. So 4 right, 10 down. And again, they said a whole bunch of things, but basically this is where we're at, and this is the angle, and this is my coordinate plane. So I got to go 4 squared plus 10 squared is 116. And 116, I should simplify this. 4 squared plus negative 10 squared equals r squared. That's 116 is r squared. R is the square root of 116, which simplifies to 4 square root 4 square root 29, and that would be 2 root 29. So I should use 2 root 29. And they were just looking for the sine. I think they just wanted the sine. We could do them all. Sine of the angle equals opposite over adjacent. First thing I should do is I should simplify that. Square root of 5, negative 5 over square root of 29. And then I should multiply the top and the bottom by the square root of 29. So I get this nasty looking guy here. Negative 5 root 29 over 29. Okay, quadrantals. This is going to be the ones that are going to lie on the axis. So we're really talking about at 0 degrees and at 90 and at 180 and at 270. And then 360 and 0 are the same. And if you take a look at how this is going to kind of work itself out, if the sine was equal to the y over r and the cosine was equal to the x over r, then you can kind of do these with the same ideas, except the y coordinate here at 0. So the sine of 0 degrees is the y coordinate divided by r. 0 divided by r would be 0. The cosine of 0 degrees would be x coordinate divided by r, which is 1. So there's a little bit more going on here, and there's a few different ways we can look at this. One of the ways you can do it is by using exactly what I just said. We can use these guys. The sine is the y over r, and the cosine is the x over r, and the tangent is the y over x. Now, if you do that, you need to understand that this is coming off of a so the x coordinate is 0, the y coordinate is -2, and the r is actually +2. This would have a radius of 2. So if you're going to work that way, you got to kind of utilize that. So if we just use our x, y, and r, I have an x and a y and an r. I could go the sine of this would be of this value theta, which happens to be at 270, be the y coordinate divided by r divided by 2, which is -1. And then the cosine would be the x coordinate divided by r, which is 0, and the tangent is the y coordinate divided by the x coordinate, which is undefined. And then the other three we got to flip over. Cosecant, flip over -1, it's -1. Secant, flip over 0. If you flip over 0, you get undefined. And the cotangent, you flip over undefined and you actually get 0. Now that's one way to look at that. I am going to look at one other way that we can do these. Some people like to do this better. Depends on where you are with your understanding of what's going on here. I could think of this as going 0 to the right, 2 units down, and having a radius of 2 by using a radius of 2, knowing that we have to have 0 squared plus -2 squared, so that's a 2. And then I can use this, and now I can just do SOHCAHTOA. So sine is equal to the opposite over the hypotenuse, -1. The cosine is the... So this triangle does not exist. This is impossible to go 0 right and down 2. But it gives us an opportunity to utilize our SOHCAHTOA, which is opposite over adjacent, which is undefined. And then you flip, 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 and you're okay. So we can either use the coordinates. If you use the coordinates here, x, y, and r is 3. But you got to know that the sine is the y over r, the cosine is the x over r, and the tangent is the y over x. Y over x. So you can plug those values in. If you like this better, I go 3 left, 0 up, and have a radius of 3. Because I went 3 left, I know that my circle here would go around, and it would be 3 out all over. So now I can use this triangle that does not exist, and I can say the sine is the opposite over the hypotenuse, or 0. The cosine is the adjacent over hypotenuse, or -1. The tangent is the opposite over the adjacent, or 0. And when I flip these over, I flip over a 0, I get undefined. I flip over a 1, -1, and get -1. I flip over a 0. Notice it would turn into -3 over 0, and I get undefined. Reference angles. We've been talking about reference angles. Reference angles is always formed with the x-axis. The x-axis. So no matter where you go, you're always making it with the x-axis. People who get these wrong make it with the y-axis. Don't be that person. I saw something somewhere in my math where it's always going to be in the bow tie. You have to be in the bow tie. No matter where you are, one of these 4 will always be your reference angle. Okay? That's because the bow tie would be inside the, would be with the x-axis. So sketch 330, find its reference angle. Boom, 330. How short am I? I'm 30 short. Reference angle is 30. Sketch -5 pi over 6. Maybe you need to change this into degrees first. Depends on where you are. I'm going to do it quickly. It's -150. Okay, so I go -150. How short am I of coming all the way up to -180? I'm 30 short. 30 would be the reference angle. If you need to change it back, 30 degrees is equal to pi over 6 radians, and you could use your dimensional analysis. 150, boom, 150. I'm there, and I have a 30-degree reference angle. And the reason we're getting all these 30-degree reference angles is we're going to use our 30, 60, 90s. Negative 3 pi over 4, that's negative 135. Okay, so find that first. Reference angle is 45. 45 is equal to pi over 4. Remember, if pi is 180, pi over 2 is 90, pi over 4 is 45. Boom, that's a great way to do it. 3,510. Well, 3,600 would be all the way around some 90. That actually ends up right here down at 270. I don't like a reference angle for that. This is a terrible problem. Okay, we do not use this chart right here. I do not like this chart. What I like better is if you know that the sine is always going to be the y-coordinate over r. The y-coordinate will always be positive in quadrant 1 and quadrant 2. Therefore, the sine's always positive in quadrant 1 and quadrant 2. The cosine is going to be, cosine of an angle is the x over the r. That means the cosine, the x-coordinate is positive in quadrant 1 and quadrant 4. And then the tangent is the y over the x-coordinate, which means you're taking the y, a positive divided by a positive, so it's tangent there. And then it's also a negative divided by a negative, so it's there. So what I do is we should know that everything is positive in quadrant 1. All are positive in quadrant 1. And then I like to do this rather than having this big 24 grid, the sine, and then the tangent, and then the cosine. And I like to go St. Cloud, STC. We go chillin' in the STC. This tells you where they're positive. The sine is positive in quadrant 2. The tangent is positive in quadrant 3. The cosine is positive in quadrant 4. And since the sine is positive in quadrant 2, the other two are negative. And the tangent is positive here. That means sine and cosine are negative. The cosine is positive in quadrant 4. That means sine and tangent are negative, and they're all positive. So they all have two quadrants where they're positive, and then you can do that. And then we're going to utilize these. We should know these, okay? If you don't know these yet, you're going to know these. Find the exact value of 135. Exact value means we are not typing it into our calculator. We are getting simplified square root form. So the first thing I'm going to do, step 1, is find your quadrant and use your STC for positive or negative. So I'm going 135 is in quadrant 2. Sine in quadrant 2 is positive. So I know that the sine of 135 will be a positive number. I know the reference angle, number 2, find the reference angle, and that's going to be, I am 45 short of getting there, so 45. And then 3, I use a reference triangle, and in this case, I'm using the 45, 45, 90, which is 1, 1, square root of 2. And I know the sine is 1 over the square root of 2. I get positive 1 over the square root of 2. I probably need to adjust that to square root of 2 over 2. That's the exact value. You put 0.707 on the test, you get no points. 7 pi over 3. Crap. 7 pi over 3. To get rid of pi, go to degrees. Boom, 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 boom. 6, 420. 420. Question 1. Find quadrant. This is in quadrant 1. Everything is positive in quadrant 1. Step 2, get a reference angle. Now I'm going to use a 30, 60, 90. 1, 2, square root 3. I want the cotangent. I never work with cotangent. I always work with tangent. The tangent is square root 3 over 1. So the tangent of 7 pi over 3 is positive square root 3 over 1. That means the cotangent of 7 pi over 3 is flip it over, and then I should probably multiply the top and the bottom by the square root of 3, and we are good. 120 sine. I go right here. I'm in quadrant 2, chilling in the STC, has to be positive. I have a 60-degree reference angle. Bust out your 30, 60, 90. 1, 2, square root 3. I'm at the 60, opposite over hypotenuse. I get square root 3 over 2. Oh, these are going fast. 315, cosine. Come around here. Quadrant 4, positive, chilling in the STC. The cosine is positive. I'm a 45-degree angle. Bust out your 45, 45, 90. Isosceles, her legs were the same length. All right, opposite over, adjacent over hypotenuse. Cosine of 315 is positive 1 over the square root of 2. Work it out. It's square root 2 over 2. Rock on with your bad self. Do some homework. Have a good time. See you tomorrow.